Hello everyone, I'm Daniela from the Center for Law and Economics here at ETH, and today I'm very happy to be talking to Professor Saul Levmore of the University of Chicago Law School. I'm quite honored to be talking to him about algorithms. So the title of the paper we're going to be discussing today is Competing Algorithms for Law, Sentencing, Admissions and Employment. And quite happy that algorithms have made it possible for us to do this via Skype from Zurich to Chicago. So hello to Professor Levmore.
Greetings. Nice to be here.
So, Professor Levmore, if I could ask you to kind of shortly summarize the paper just to get us started.
Certainly. Well, I invite everybody to read the paper. So algorithms have made a big move in many areas of life. And part of the argument of the paper is that algorithmic improvements are easy when there are huge sample sizes. So you have 10 million observations. Algorithms can do a lot of playing with them, of omitting variables, adding variables, and so forth. They can never solve the problem of unrecognized omitted variables. This may be a problem in law as well. But algorithms have entered law. It's a much touchier field because the sample sizes are much smaller. So, for example, if we're trying to decide whether to release a prisoner early because we don't think the prisoner will be a recidivist and commit another serious crime, we rely on judges to do that in the past. And now it's been shown that sometimes an algorithm can do better than the judge. By better, we mean holding some things constant. Will the algorithm do a better job of releasing a similar number of people and find fewer recidivists, find fewer crimes in the future? And at least in one important study, the algorithm outperformed the judge. The paper shows some questions with the literature, but let's assume that that's true. The paper takes up the idea of, well, where does this algorithm come from? The common reaction is to say, ooh, the algorithm might be dangerous. It might be using things we don't want to use, like the incarcerated person's race or other things like that. Mm-hmm. What we try to show in the paper is that it's actually very hard to develop these algorithms. We don't want to give away what the algorithm is doing because then it's like a trade secret. Everybody will copy the algorithm. There'll be no incentive to come up with better algorithms. Instead, what the paper suggests, as perhaps you can tell from the title, is that instead of the state spending money to pay people to develop an algorithm, the state ought to open it up to a competition. Lots and lots of people, even kids, can compete to try to come up with better algorithms. And the way to do this is to divide the data in half, give people half the data, and say, why don't we have a competition to see who can come up with the best algorithm? And best will mean that you do the best job of predicting on this separated data that we didn't let you see in advance. So we won't have a problem of overfitting or retrofitting, as we call it. Mm-hmm. And then there'll be a winning algorithm out there, and we'll use that in the future. And we try to show that you could do that for university admissions, for other areas. But I think the area where it has the most bite is in trying to decide how long to keep people incarcerated. So that's the general idea of the paper.
Mm-hmm. Okay, right. That's very interesting. So I think the first question I'd like to ask is, you mentioned in the abstract that this has advantages over transparency. And you've already alluded to some of the kind of problems with transparency, retrofitting, maybe also gaming the algorithm, playing with it. Could you just kind of elaborate a bit on why you feel competitions might be a better way to go?
Well, the answer to almost every question in my life is competition is probably a better way to go. But I teach at Chicago. That's what we do for a living. But I'll try to limit it to algorithms. I mean, basically, retrofitting is a major problem in all empirical work. Mm-hmm. So if I want to show that I should be regarded as innocent, I can look at all the data about all people who commit crimes. My first name is Saul, S-A-U-L, and then I'll try to look for something about names. I'll try to show, oh, we've never had a criminal be a recidivist whose third letter of his first name was U. You know, I can find some accidental feature that matches me with all the innocent people. And I can just keep looking at characteristics that I have, at the color of my tie, the letters of my name, until I find something that happens to work. That's what we mean by retrofitting. Mm-hmm. Seeing all the data enables me to come up with some trick that makes me look good compared to the data. On the other hand, when I come up with that trick, if you then make me show that works for data I have not seen in the past, it's much more likely that my trick will fail. Mm-hmm. And that's the idea of separating the data. So we need to hide the data from me, maybe hide the data from everyone, But it's not just a matter of giving people an incentive, it's also a matter of hiding the data. Another way to think about it is in investments. If I can look at everything that happened last year to stocks and use that to predict what will happen in the stock market, it's useless to make the winner the person who can predict what will happen to last year's stock. Because we can see what happened to last year's stock. And if I see company X went way up in value, I'll come up with an algorithm that provides, X will be the stock that wins. Oh, well, of course, X wins. What I should do is try to come up with an algorithm that will predict how X does next year. That is in data I have not seen.
Mm-hmm. So basically, by having this competition, you're both tackling this incentive problem, but also actually you might be improving the quality of the algorithms that come out of the competition.
I don't think just might. I think surely.
You surely will. Yeah.
Yes.
Yeah.
You don't get to look backwards.
Yeah.
You can look backwards to try to develop an algorithm, but the real test is to see how it performs on separated data.
Yeah.
This is, by the way, something that's very quite common in the statistics world, very quite common in the investment world today. For reasons that are beyond me to understand, it has not made it into law and economics, so this really troubles me. The paper actually shows that you might want to divide data, if you have enough of it, into more than 2 sets, say into 3 sets, because it might be that new factors will be developed, or after we have a winner on the second set, somebody comes up with another algorithm or new cases. So ideally, you might like to do many separations or separate over a period of years. But the idea, the principle is the same.
Yeah. Yeah, so if I can just keep on this kind of quality argument of how can we get the best algorithms. So one thing that I didn't fully understand is that on one case, on one hand, you're making the argument that we should open this competition up to everyone and basically have students, children, as you said, try to make these algorithms. But then on the other hand, some of these algorithms are very difficult to develop. You might have to have sophisticated experience and knowledge. So the barriers to entry to that competition, I fear, might be high.
Well, there are these websites that do this, and maybe to the surprise of people my age, high school students win a lot of these algorithm competitions. I mean, I guess if you have a lot of time and your parents let you sit in the basement all day, you could beat sophisticated people.
Yeah.
So there's software that helps these unsophisticated people. It's true that the sophisticated person might have a better idea of what to look at. So in some industries, experience really helps. For example, there are algorithmic competitions to see how many people will go watch a movie. And there, it turns out that the winners are almost always people who are in the movie industry because they have a sense of what movies succeed or not. A sense, meaning they didn't do it with fancy computer science. In other areas, ignorant people seem to do just fine by not being biased and using the algorithm to discover connections that those of us who think we're sophisticated have not thought of before. That's a good way to think about algorithms, that it's finding correlations. It's not trying to prove causation, but it's finding correlations that we did not imagine in advance.
Yeah.
That's the advantage of the computer looking at large data sets.
If you let it run unsupervised, of course, as you discuss in the paper.
Now, I do have another paper, just to sound like an American academic, that tries to show why you actually need a theory to back up most algorithms. So you wouldn't want to have an accidental winner. You'd want, in retrospect, to have some theory about it. It's a little bit like medicine. We have some famous medical advantages that just work, and we don't know why. But they're not really trustworthy. I mean, often after a while, it turns out we have the wrong connection. So over time, you can use the algorithm, you can use the statistical result to train your eyes to look for some theory that explains why that result worked. And usually over time, we then come up with a theory about why that drug worked on that disease. If we go for a long time and the theory doesn't develop, usually the empirical data falls in its use.
So another question that I wanted to ask is just, and you're going to think of me as a very much European scholar now, but couldn't you say that this is outsourcing of governmental obligations? So there are these other proposals in the law, say the right to explanation or the kind of keeping of the human in the loop, so retaining human intervention, that would give these obligations to the state, basically. So the right to explanation the administrative would be obliged to do all of that work. Whereas now with the competition, it's somewhat outsourced to private actors.
Well, that is a breathtaking European question. I don't really know how to answer it. I mean, I guess we
Yeah.
can study.
No, I mean, I posed the question too broadly, but kind of sticking with this defendant case that you discussed a lot in the article. So kind of the defendant in a criminal case or in an administrative case, and then we're somewhat outsourcing part of this procedure. That is what I'm asking.
Well, that's fair. Then I think I understand you better now. That's fair. So we think the government, with some input from its citizens, is best at deciding what's a more serious crime than something else, and tends to give a bigger penalty for one than the other.
Mhm.
It might learn over time that the penalty does a good job there and does a bad job there. It gets a lot of recidivism. It's only outsourcing in the sense that it's outsourcing information gathering and intelligence. It's not required to follow the algorithm.
Mhm.
But the government can also look to other countries and see their success with criminal penalties or not, and then decide, oh, we should lower our penalties for this crime. We don't think of that as the government giving away its responsibility.
Yeah.
The government's using information that's available. I think the more it outsources the finding of information, probably the better it is.
Mhm.
Just like we don't think the government should declare one university the right answer for everybody. In a sense, it outsources. It has a number of universities, even if they're all government sponsored,
Mhm.
and then it tries to see whether good ideas come from one university more than another. That's also a form of outsourcing, though it's
Mhm.
within the government. So that's really what this outsourcing does. It's only pointing out, like inventing products and giving intellectual property protection,
Mhm.
the government is probably not the best inventor of all. It outsources invention to people
Mhm.
who can come up with good ideas in their houses, and then the government rewards them or protects them. And the same thing here with information about recidivists and crime.
Yeah, and I think that is one of the big advantages of a competition like this, right? That there's no inherent reason for it to be limited to, say, for example, the city of New York, or to have these algorithms be limited to. I mean, the competition could be global. Competition could be anyone could participate in it.
Certainly. Actually, when I gave this paper the previous time, that came up, and it made me think even stronger. We might like it better if it was outsourced far away, is the way I'll describe your question, because that might take it away from interest groups or payments to the government to do some things rather than other things. So it might be more unbiased if it was outsourced far away.
Yeah. So I'd love to continue talking about this, but we're kind of running out of time. So I just wanted to give you the chance to say a few final words about the paper and why everyone should, of course, read it.
And see the movie. The movie's better.
Yeah.
That's also an outsourcing by the government. No, I'm very happy if you were able to watch this. And if you have comments, I'll be happy to hear from you. You can find my email on the University of Chicago Law School site. And good luck with your own work.
Great. So thanks a lot, Professor Levmore. Thanks everyone for watching. And we'll see you next time with the CLE series.